So, hello students, welcome to the model number 2. Now we are going to discuss about failure of materials in that very important concept, that is the SN curve and RR Moore fatigue test. First, we will discuss about SN Moore curve. Okay, so why this is very important? This is the basic method of presenting the engineering fatigue data by means of SN curve. A plot of stress S against the number of cycles to the failure, that is N. So this curve it shows that based on the number of cycles against the stress. So stress is plotted on the y-axis and number of cycles produces on x-axis. Okay, here the stress can be sigma a, sigma max and sigma minimum. So this will be concerned chiefly with the fatigue failure at the high number of cycles. That is that n value is greater than 10 to the power of 5 cycles. So and high cycle fatigue is this much. Okay, and low fatigue means it is less than 10 to the power of 4 or 10 to the power of 5. That is the low cycle fatigue. So as n increases, so decrease in stress level. So let us see with the figure how it is going to be happen. Okay, so I have connected for the only two materials for this. One is mild steel and this aluminium. Okay, so this figure shows that typical SN curve for the maximum and carbon steel and okay, maximum carbon steel and aluminium. Okay, these are all the two materials I have taken for your SN curve for diagram to understand this concept. Okay, this SN curve or fatigue life curves service a useful way of visualize time to failure for the specific material under this particular stress. You can see here at the bottom the number of cycles will be around from 10 to 5 to 10 to the power 9, and along the y-axis you see the stress condition will be 100 megapascal to the 400 megapascal. So this is how they are going to plot the graph for the SN curve. So from this graph it is clear that for aluminum alloy the stress is cause failure decrease as the number of cycle increases. You can see the graph. So for the aluminum, what happened? For the aluminum, the stress is to cause failure because of decrease as the number of cycles are increased. See, as the number of cycles increased, the stress is going to be decreased. So, in other words, the fatigue, the number of, in other words, what we can say, the number of the cycles increased, the stress decreases, and this fatigue strength decreases, the number of cycle is going to be increased. But for the carbon steel material, initially there is a decrease fatigue in strength as the number of cycle increased. At certain limiting stress, we can see here from the point where it is going to be starting this SN curve becomes constant. There is a horizontal line here for the mild steel. So as the number of cycles is increased, this is limiting the stress is called fatigue limit, and it is in the form of important characteristics of the SN curve. So these are all about the SN curve for the analysis of the fatigue test. So how it is going to be conducted, this fatigue test? So that we will discuss in the next slide. Okay, that is to conduct the fatigue test, we have one equipment, that is RR Moore fatigue test. Okay, how we are going to conduct the universal testing machine under various tensile test, compression test. Here also you can find out the different that is a fatigue test under this device. Okay, so how it is going to be work? This fatigue test can be done carried out in a number of ways depending upon the type of load used in a initiated propagations. Okay, and this machine is consist of a bearing housing, and specimen is going to be placed here. Okay, here what we are showing, that is specimen is going to be placed, and bearing housing again it is going to be collected. This is both the sides are taken a load here, okay, and this is the flexible coupling, and this is the high speed motor where it is going to be rotating, and it is a counter. So let us discuss how it is going to be work. So this is the most commonly used for the small scale fatigue test. It is in the rotation beam of the test machine. Okay, and this machine is consists of mainly, as I told, there is a electric motor and bearings and collets of support of specimen and other revolution things. Okay, this specimen is loaded by attaching weights in such a way that the specimen is going to be under the effects. Okay, when this specimen is rotated by the motor, the lower surface at this center point of the specimen will be under tension. So while the upper surface at the center of the point is going to be under compression, then specimen while rotating the subjected to the alternate tensile and compressive stresses. Once the revolution counter records the number of cycles applied to that specimen, and when the specimen breaks, counts the automatically and disengages. So the number of specimen of the same material are going to be tested under this stress level. Okay, so usually the stress level will be decreases because the results are plotted on a semi logarithmic graph. So that is called SN curve. Okay, so this scale will be a stress amplitude, that is y-axis will be a cycle. Okay, number of cycles along with the x-axis will be number of cycles, and along y-axis will be amplitude. And this specimen on this graph is called as SN curve, and this we will call it as fatigue life or fatigue life curve, and it is also used portrayed within the 10 to 12 per specimen. As the result of fatigue tests are analyzed and concluded based on the SN curve obtained. This is about the conduction of RR More fatigue test, the method of conducting the RR More fatigue test. Okay, so I hope you understood this concept. I will discuss some more slide in the next video. Okay, so I hope you understood this concept. I'll conclude this video. Thank you.